My name is Richard Hamilton. I'm going to show you flint knapping. I've been flint knapping for quite a few years. It is a very dangerous proposition to do this. You can get silicosis from it, from the dust, so you prefer to do it outside. It produces such sharp edges you can literally slice yourself and cut yourself extremely badly. So if you're going to try it, you do it on yourself and your own recognizance, because the simple fact is, I'm telling you, it's dangerous. And so you can take classes on it. There's flint knappers that will give classes on it. There are flint knap-ins you can go to. There's sources that you can buy raw material from. So what I'm working on is a piece of chert. Chert is nothing more than silicon dioxide. It is microscopic quartz crystals that are homogenized and bound together with the rest of the matrix of the rock. So our ancestors in Africa, Egypt, Asia, you name the country, they were flint knapping. And so a simple fact is, even here in North America. So this is chert from Oklahoma, and it's silica, microscopic quartz crystals that are homogenized and bound together with the rest of the matrix of rock. So I'm going to strike it here on this platform and run a flake with this ridge. And so I set up a platform that I'm going to hit, and I want to control how the fracturing occurs. And so if you can control something, you can make something. So what you're doing when you hit it, you're introducing energy into the stone. That energy travels in a conchoidal shape or a cone-shaped wave. And so it ran that ridge, so now it produced a ridge and another ridge. I'm going to hit now along this ridge, set up a platform right there, and do the same thing again, but using this ridge to direct the flow of energy. Because I'm trying to get a center line in this stone and control how much I'm taking off. So here's my ridge, here's my platform. It ran that ridge. It might have broke, but it ran that ridge and it took material off. And once it does it again, it produces two ridges again. So you're working off ridges or mass to direct the flow of energy. And so that's the reason why flint knapping works. And so you're understanding outcome. They may not understood the physics or the reasoning why it works, but they understood outcome. And if you can predict outcome, you can make whatever you want. So flint knapping is nothing more than producing tools by taking conchoidal fractures and shaping the rock the way you want to. That's flint knapping. And it is ultra sharp. They're like razor blades, and they will cut you. I guarantee it. You will bleed. And so why flint knappers take along Band-Aids, because the simple fact is you're going to cut yourself. And so I'm taking small flakes off, setting up a platform. So my platform's right here, so I can take another flake off there. And what it is just a game that you're playing of shaping the rock and imparting energy each time you hit it and directing that energy. And so now we have a center line here. So we look on this side, we have a line here that'll be easy enough, but we got a square here. And so we have to take that square edge off. And so we're going to use that ridge to direct the flow of energy. And all it is just back and forth to introduce energy into the stone, so you can shape the stone in whatever way you want to. And so our ancestors were producing adzes, axes, hoes, spades, arrowheads, knife blades, spear points, whatever tool they wanted to make. They used from flint to chert, and this is chert. And so what I'm doing is cleaning up the stone so I don't have any big divots in it, any big holes, pockets, or anything else, so I can start shaping the rock to what I want to make out of it. So I'm taking that square edge away. So our ancestors understood, they may not understood the physics and why the stone was working, but they understood that certain stones had certain properties that allowed them to strike the rock, produce a sharp edge, and shape the tool that they wanted to make. And so our ancestors, and wherever they came from, understood that certain types of material would benefit them to produce a sharp edge. And so that's all flint knapping is shaping the rock to whatever type of tool that you want to make. This is chert. This happens to be obsidian, volcanic glass, true flint. And so that's chert. Here's flint. Flint formed in chalk, chert formed in limestone. This is a piece of true flint. And it breaks the same way. It produces conchoidal fractures. So I need to take this cortex off. And so I'm going to find a platform, and it ran all the way down to there. It produced a ridge and another ridge. The same thing. It produced a sharp edge. These edges are like razor blades. So now I want to come back, set up, use this ridge here, and do the same thing. But I'm going to wait. I'm going to come back over to here and use this right here and hold the middle. Come on. There we go. And so some of these flakes can be used as arrowheads. There's enough raw material there. So now I have a distinct ridge here that I can basically drive a huge flake right down that ridge. We'll set our platform up and see how much. So there we go. So now that's how much cortex we took off. So now we only have a little bit left there to take off. So now we're going to come back. And now we're going to start taking off on this side and doing the same thing. And so I want to set up a platform here and see if I can get one more good flake. There's a real good flake for an arrowhead right there. So I'm taking it apart, but I'm using the stone wisely so I can get as much usage out of I can. And so, yeah, I want to make a biface. I want to make a big blade out of this, but I also want to save as much of the raw material I can for doing something else with it. And so that's the name of the game. You're trying to do a finished piece, but you're also trying to save as much as you can so you can get as much raw material out of it as you possibly can. So again, I'm setting up a platform. We'll strike, take this way. All right, we have now this. Hopefully we can take most of that off. We have enough raw material here for an arrowhead, so we saved material right there. So that almost cleaned this whole face off. Now come back, do the same thing again. And so what you're doing is trying to reduce the thickness, but save as much as you possibly can on each flake. But I have to get this chalk cortex off. I also do flint and steel. So a simple fact is I need steel striker material. In other words, things that you can make sparks with. So I save the raw material so I can sell the raw material for sparkers. In other words, to hit the flint with the steel against the flint. And so I have a strong ridge here. Now that's curved. Now there's no way I can get probably an arrowhead out of that. But for a steel striker, it had plenty of sparks. So you save the raw material. So that face is totally cleaned off. So now I just work on the other opposite face. So people ask me why and how I learned how to do this. Well, umpteen years ago, the original director of Boone County Conservation District, which I worked alongside because I banded birds for use, fish, and wildlife, said, buy this book. And it was a book of flint knapping. He said, learn how to do it, and I want programs. So that's how I got into flint knapping. So that face is, that went from that ridge all the way over, extended, and ran with that ridge, these two ridges right there, and that's flint knapping. And you just keep shaping it down until you get it to a point where you can just pressure flake the edge and make whatever you want to. That's it. That's flint knapping in the nutshell, is that you're introducing energy into the stone and then shaping the stone the way you want to build whatever you want to build. And by taking the stone apart, flake by flake, piece by piece, and you control the fracturing because it's made up of microscopic quartz crystals. Those quartz crystals are homogenized. They're bound together with the rest of the matrix of the rock. So in other words, they're all stirred up and bound together. So when you hit it, it produces a conchoidal fracture. And you say, well, what's that? Well, glass is 99.9% pure quartz crystal. So a simple fact is, when your neighbor gets a Red Ryder BB gun for Christmas and he's trying to put his eye out, he misses his eye, but the little round BB hits your plate glass window. On the outside is a neat little round hole, but laying on the floor is a cone shape of glass. And the mathematical terminology for that cone shape is called a Hertzonian cone, because the energy traveled in a cone-shaped wave. And so you're just working on part of that cone-shaped wave. That's all you're doing when you hit it. So you're introducing that energy, and it flows through the stone in a conical shape or a cone-shaped wave. And you're just taking part of that. And so we have a good platform here. We can run right there, a flake right there, and reduce over to this side. And so it's just a game that you play of where my platforms are, where I'm going to strike, how I'm going to hit it, the angle I'm going to hit it, and that's the game. And so it's understanding the outcome, what's going to happen. There's a good arrowhead flake right there. And so that ran halfway across. It produced a ridge and another ridge. So we want to come back here to this. We're going to have to do a little work, set that platform up. We don't have to hit it quite as hard. So that is true flint. Flint formed in chalk. It is about 70% silica, where chert is around 30 to 40% silica. But here in Illinois, we have chert. It formed in limestone. Limestone was formed in the bottom of the inland sea. It's all the sediments that got piled on top of each other, the dead animals, the dead plants. That's what you find as fossils. And the silica slurred into holes and pockets. And then more and more of the sediments piled on. You had an uplifting after I don't know how many years. And that compression of all those sediments produced the limestone. And then as it got pushed up, the water ran off. It dried out, and that's what you have is a silica. Now, there's a silica in Australia called opal. You can flint knap opal. It'd be a little expensive, but I know knappers that will flint knap opal even. So a simple fact is there's a lot of different forms of silica. You know, so you can do jasper, agate, you can do all different forms of silica. And so this is just a couple of them. Now, obsidian. Obsidian is volcanic glass. This is a mineral oid, totally different than chert or flint, but it produces a conchoidal fracture also. And so you don't have to hit it quite as hard or anything else because it breaks fairly easy. But the same way, where you have ridges or mass, you direct the flow of energy. And so I have a good ridge right here. We'll set up a platform. So here's my platform. We'll abrade it. And we have a square edge here, so we'll take it hopefully all the way to the edge, and we did. And so we're going to come and we're going to reduce this square edge. Same thing, we use the ridge here and the ridge here to direct the flow of energy. No difference. We have a fracture in here. This is black opaque, so I know something about this stuff. It has a lot of times a lot of interior fractures. That's a clean fracture here. How deep it goes, I have no idea. But we'll work around it and hopefully, and there's a fracture there. So sometimes you don't know the internals of the rock until you start opening it up. And black opaque has a lot of times a lot of cracks in it, a lot of fractures. And so you work around those cracks, try to eliminate them, and you see that crack is literally down into there. And so this is probably not worth even working on because it's got internal cracks that it'll just keep breaking. The edges of this are so razor sharp. I'll show you how sharp this stuff is. And people don't quite understand how sharp this stuff is. Now, there's the fractured edge. You can see how thick this leather is. And I'm just, that is ultra sharp. It is sharper than anything that man made today because it's down to, the edge is down to two microns. And so if we can make a man-made edge down to 2 microns, we're doing it extremely well. And it will get dull in time, don't get me wrong. It will not stay that sharp. As it's being used, it will get dull. But you can see why it's going to cut you. All it has to do is break off and touch your skin in a certain way, and it will cut you. And so a simple fact is, that's why it's not safe, and you have to wear safety glasses. I recommend that you put a mask on so you don't breathe the dust or do outside. And wear, as I said, eye protection, because the stuff will fly up and it will hit you in the eye. And so that's the safety portion of it. Now, pressure flaking, I was working on a piece right here where we started. Now, I'm starting to shape it, get it into shape, get it into line, and pressure flaking is doing the same thing that percussion did, but it's very, very small flakes. It's all the same thing, nothing changed, and the least little bit other than the amount of energy that you're imparting into the stone. That's the only thing that's changed, the size. So we want to start taking flakes across here and shape the stone up. This is called pressure flaking. I'm imparting energy into the stone by doing pressure. And so each time the flake comes off, it produces 2 ridges. Use the energy where that ridge is that just came off to direct the flow of energy to the next flake. It's the same exact thing again and again and again. It's just understanding what that energy is going to do for you and how much energy you impart into the stone to make it work for you. And so it's understanding the game in flint knapping. And so what it is understanding the stone breaks. You understand how that breakage happens, and then you can manipulate it. You can control it. And that's all it is. No more, no less. That's flint knapping.